that you need to know for this class in terms of derivatives and integrals of exponential and logarithmic functions. So you already did an exploration, so none of this should be shocking to you. But just to review, the derivative of e to the x is e to the x, which also means the antiderivative of e to the x is e to the x plus c. So remember, antiderivatives should have a constant being added if it's not a definite integral. The derivative of any other base to the x power is going to be ln of that base times a to the x. So it's actually the same rule as e to the x, but if you were to do ln e times e to the x, ln e is just 1, so that's why it's just e to the x. So technically they're both ln base times a to the x, but e to the x is a special case. And then the antiderivative is going to be a to the x divided by ln a plus c. So I'm listing the integrals here, but really you should be able to find the antiderivative by just working backwards. Instead of multiplying by ln a, we're dividing by ln a. All right, the derivative of ln x is 1 over x. So that's another fun special rule. And the derivative of log base a of x is equal to 1 over ln of the base times x. Again, this is a special case because this is log base e. And if you were to do 1 over ln of e times x, ln e is just 1. So you get 1 over x either way. So those are your rules for logs and exponentials. So let's do a quick example. Find the derivative of x times e to the x times ln x. So can you simplify e to the x and ln x when you multiply them? No, you cannot. Ln of e to the x would cancel basically, and they would undo each other and you just get x. But when you're multiplying them, you cannot just like cancel stuff. So make sure you're not. Like, I want you to simplify when you can simplify, but you can't simplify in this case. Okay, so we're multiplying. So we're going to use the product rule. And I'm going to go ahead and let this be f and this be g. And then the derivative of y prime would be f prime g plus g prime f. You guys know product rule. All right, so that's going to be f prime, the derivative of x times e to the x. All right, here's the thing. F prime is going to need the product rule in and of itself because the derivative of x times e to the x is going to be, we'll call this like h and k. That would be h prime k plus k prime h because f is a product. So I have to use product rule within product rule for this one. So f prime is equal to the derivative of x, which is 1, times k, plus the derivative of k. So the derivative of e to the x is e to the x times x. And that gives me, again, this is just the derivative of this part. So I have product rule within product rule for this one. All right, so then going back to my derivative, it's going to be f prime, which is e to the x plus x e to the x, times g, which is ln x, plus g prime, the derivative of ln x is 1 over x, times f is x e to the x. Okay, so this I can simplify a little bit. I get y prime is equal to, well, this I can't really simplify. It's just going to be ln x times e to the x plus x e to the x. I could like factor out an e to the x if you wanted. Like you could have ln x times e to the x times 1 plus x. That also would work. And then this I can simplify to just be e to the x. You could also rewrite this just for funsies. This is ln x times e to the x plus x ln x e to the x plus e to the x. You could also factor out e to the x from all of this, ln x plus x ln x plus 1. Like there's a lot of different ways to write these. If this is a free response problem, I am okay with any one of those answers. Just make sure that you recognize, because it's usually multiple choice that these problems show up, that you recognize what the answer is based on how you did the problem. But any of these answers is totally fine.